And welcome back. Now this week we're going to be talking about a very simple project. It's that one in the middle there actually. And as you can see, it's a bare ATMega328P chip surrounded by some bits and pieces, which makes it look a lot more complicated than it really is. Believe me, there's nothing complicated about this. But as I say, this is really a beginner's project, right? Now if you're new to the Arduino world and you've got your Arduino Uno or Nano, something along those lines, you think I'd like to do more than flash an LED or beeper a sounder. Well, you'll get to beeper sounder here, as you can see, but there's a little bit more to it here. Now what this project is, it arose out of well, my cat Benny, which lots of you know. He's caused me quite a bit of trouble lately. Not that he'd understand the word trouble, he's so sweet, but he's caused me trouble. And then, would you believe, a neighbour down the road had the same sort of trouble. What's that all about? Right, a 30-second summary on what this project's all about. Basically, Benny my cat goes into my airing cupboard where we keep all our linen and, more importantly, the hot water cylinder. Unknown to us, he sneaks in and he could get hurt in there basically, but he likes it because it's warm initially, but then he could boil to death. We don't want that. And the neighbour up the road has got a cat who can't even meow, and that cat got locked into a kitchen cupboard for about 17 hours and he didn't know, except purely by coming home after work and opening the door, and he jumped out. So this project is to prevent that sort of thing happening. So it's going to be movement detection, a sleep enabled Arduino, and a beeper basically. As you can see, this project is not complete. It's only on a breadboard at the moment. The next stage is to go to KiCad and put the circuit diagram down, and my sponsors have indicated they'd be more than happy for me to put this onto a PCB, and the PCB is not going to be that huge, so I'll probably get maybe 2 per panel, which means I might have some left over to give away in a future video. But that's for a future video. Right now, let's have a message from that very sponsor who makes this video possible. I'd like to give a big shout out to my sponsor, PCB Way, PCB Prototype the easy way. Let's have a look at their new Superior A+ Advanced PCB. Here you can find all the details of what their advanced PCB service consists of, and there's a handy comparison table to see the benefits of the advanced PCB service. Scroll down to the PCB showcase and you can see some examples of what they can do for you. Just go to their easy online PCB instant quote page and select the advanced PCB option. Simple. If you have advanced requirements for your PCB, try PCB Way. Try them now. Okay, and as I say, we'll be talking more to them a little bit later as we go into the PCB stage, but that's not for now. If I build this so that this unit needs a plug-in power source, it's not going to be very generic, is it? It's very specific to my particular setup. How about I create it so it can run on batteries for a long time? So that means deep sleep mode. How's that going to work with a PIR and a beeper? And of course it's got to be dark when it goes off because you're inside a cupboard. We don't want it going off in bright sunshine or when we've got the light on upstairs outside the airing cupboard. So made me think. So what we've got down here then on this breadboard is a bare ATMega328P wired up without an external crystal, so it's running on its own internal 8 megahertz clock. Okay, and yeah, got a PIR to detect when there's movement inside that cupboard. It's got a beeper to alert everybody that there was movement. It's got an LED here simply because the original circuit had one. I've just left it in for now. And at the back there, it's got a variable resistor where we can turn the sensitivity light and dark. So we can open up the cupboard, put the lights on, make sure it doesn't go on at that light level, but then as soon as we shut the door, it'll be armed effectively. Now the trick, of course, is to get this in a deep sleep mode enough so that it doesn't drain the batteries. And I'm going to run it off 3 AA batteries, which is 4.5 volts. I possibly could run it off 3 volts, but I don't think this PIR likes 3 volts that much, so I'm a bit stuck with that. And of course that beeper over there hardly makes a sound at 3 volts. It's just not loud enough. Now none of those are insurmountable, but I thought, well, let's not make hurdles where we don't need any. 3 AA batteries in a little holder, and it'll be fine. And those batteries, I reckon, will last a year, possibly even longer. Depends on how much movement there is. Now in an airing cupboard, we're in and out of that all the time, putting stuff away, dragging out bedding, putting towels in or whatever to dry. So yeah, there's going to be a fair amount of movement. So this circuit will trigger, but what this says is oh, you've woken me up, PIR. I'm awake, but hang on a minute, it's too bright. I'm going back to sleep immediately within, you know, a few microseconds. But then 2 to 3 seconds later, this says, oi, wake up. So it does wake up again. It says, it's still too bright, I'm going back to sleep. So it does wake up a few times like that when there's movement, but it's not like we're going to be opening and closing the cupboard, you know, every minute of the day. It's just a little burst of activity in the morning. And that's probably about it, really. So the big question is really, what did I get the power consumption down to? Well, with nothing attached to this ATMega328P, did I say that right? ATMega328P. So just, okay, we have the beeper attached and the LED attached, ready to indicate that it's on. Couple of capacitors, not to the PIR and not to that variable resistor. What was the current consumption? And we'll have a look at that in a little bit more detail right at the back. I'll give you a couple of, you know, screenshots of my multimeter and stuff like that showing the power. But I can tell you I've got it down to 0.3 of a microamp, which is within the spec of the datasheet. That's what it should be. So 0.3 of a microamps is absolutely tiny. It's less than the leakage current of those batteries in all likelihood. As soon as I connect up the PIR though, this little dinky one here, let's bring that around so you can have a look at it. This little thing. Now that has got a quiescent current of 16 microamps. So it doesn't really matter what I do to the Arduino anymore. I could, you know, run it at 1 megahertz, for example, instead of 8. But it just won't make any difference if this is taking 16 microamps anyway. And there's nothing I can do about that because this is acting as the trigger for the Arduino. Even if this were controlled by something else with a lower quiescent current, it takes a little while for this to stabilize, and it could be up to a minute from switch on to I'm now settled and I can start detecting movement. So that isn't really going to help. So I think you need a circuit diagram just to show what I'm going to do, and then I'm going to connect all this up and have you a quick demo. If you think, hang on a minute, I've seen some of this before, haven't I? Yes, you have. Back in video 115, we had this exact setup. Well, just with the chip actually. As I remember it though, we didn't get as low a current consumption as what I'm now getting. So I'm getting 0.3 microamps. I think at the time we got something like 14 microamps. And I think I know why, and I'll tell you the reason for that towards the end of the video as well. Right, first things first then, circuit diagram demo. Stay tuned. Remember, this is a beginner's project, but it's got some very useful details within it that could come in useful for lots of projects. So this is the circuit diagram, and believe me, it's simpler in real life than what it even looks like on this particular circuit. So here we have the chip, and these numbers, by the way, are the actual physical chip pin numbers, not as we know them as the Arduino numbers, but that you'll see what they are in the code. So basically you've got power both sides. You've got 22 and 20 here, 7 and 8 there, and the only thing you need to know about those, you have to put this 100 nano F and there, 100 nanos, either side really close to the chip to prevent any kind of instability. 100 nanos is 0.1 microfarads, so they're easy to find and cheap, of course. So the power, ground and plus goes to 5 volts, or in my case it'll be 4.5 volts, 3 AAs. So that's the thing powered up, and of course it's running on its own internal clock, because I've told it that with the bootloader fuses that we fired up earlier on. The PIR output is going into pin 26, which is Arduino pin 3. We know it as pin 3. It's an interrupt pin, and we wake it up by this pin here going high, and that goes to VCC and ground. And that's the thing that takes the approximately 16 microamps at all times. Over here we have a beeper directly driven from pin 11, which is in fact our GPIO pin 5, and also it's going to an LED at the moment. I probably won't end up putting those components in, but I'll leave space on the board for them to be put in. And the only other point of interest really is this one here. Now we have the LDR, whose resistance can be 100 ohms in extremely bright light to 1 mega ohms in extreme darkness, so you know, pitch black room. Roundabout though, we're talking about something between 5 and 30k in the sort of light levels we're talking about. And the 10k variable resistor, the potentiometer, is the bit that then goes into the analog circuit so that we can adjust it a little bit and then to ground. But the interesting bit is that normally we'd connect this to VCC, so in this case 4.5 volts. The trouble is though, if we connect this to the battery at all times, then power is going to travel down here through the LDR, through the 10K and to ground at all times, 24/7. And even if this is an extremely high resistance, say it got up to nearly 1 mega ohms, you're still sucking that power out all the time without fail, and that will flatten the battery quicker than if we didn't do it that way. So what I do is power it not from VCC, I power it from a GPIO port right from the Arduino, or the ATMega328P. What I say is, when this wakes up, one of the first things it does is switch on another digital I/O port, which is in fact pin 18 as far as we're concerned in the code. So we say set pin 18 output and write it high, which powers this, and then I say read the voltage on here via the analog port. And in that way, of course, it means the power going through here is only when we wake up and have a reason to read this value. So that will save another few microamps or even more. That's it then, really. I mean, it's really simple, and when I get the circuit board done, you'll see how few components we actually need to make this work. Okay, I've got it all powered up, and I'm trying not to move to set it off. So, it's running. Right, you're hearing it run. Right, let me explain quickly what you're looking at. One, in the top right-hand corner there, you're seeing my meter, my multimeter, on the microamps range, and there it is sitting there in sleep mode now, 15.9 microamps, but that's mainly the PIR, as I say. So I'm happy with that. Now let me disconnect the PIR and you'll see that sleep current drop like a stone. Now the reason why it's floating about like that, it might be that the trigger pin is being kept sort of floating. So let me just connect that to ground, like there wasn't one there at all. So connect that into ground. There we are. So with the trigger pin kept low, 0.5 microamps. Now, isn't it funny? Yesterday I had that lower than that. It's 0.3, but today, well, it's jittering even there a little bit. 0.4, 0.5, 0.6, but whatever. You can see that this is about what you should get from an Arduino that's in deep sleep, even allowing for the fact that I've got some other components connected to output pins. One of the things I do to all those pins is set them all to input, and then only the ones I actually use do I set them to output. Now, the ones that I actually need as output, like the beeper pin, right, I should really, before it goes to sleep, I should set that to input as well. And then when it comes out of sleep, set it to output mode. That would actually save a little bit more. And it might be why I was getting different results yesterday, because I was doing this without having anything connected at all. But as you can see there, all the current has been taken by that PIR, and I don't know any way around that. Now you may have noticed this bigger one here, and that took even more current. I think it's even got an LED on the back, and it's got more components and everything else. So that was a non-starter really. I don't think these were going to work great for a battery-powered project, which is a shame, because the two little variable resistors you see on the front there, one is for sensitivity and one is for on time after triggering. So the minimum on time is about 2 seconds still, and the sensitivity can go right up to about 7 meters. It was pretty good. I was even considering one of these for the Home Alone project that I did, but basically they're just too big and clumpy. So I decided against that. And in fact, I've got some more of those little tiny ones on order because I've run out. In fact, I've borrowed this one here from the Home Alone project because I didn't have any spare, would you believe? You can get these in various incarnations. You can get them with a slightly longer PCB, which I didn't like. It just means there was more leverage on those pins. I didn't like that. And this one, it's simple, it works, not a problem. And they're reasonably cheap, actually. I got these from Banggood, but even if you bought them locally, you're not going to spend more than about $2 each. Now I bought, I don't know, 5 I can't remember now. We'll have a look on the Banggood website, but AliExpress sell them. Hobby Components in Britain sell them. So I mean, there's lots of options to get in these little tiny ones. And although you haven't got any adjustment on them, I found the range to be about 4, perhaps 5 meters under ideal conditions. With this little lens straight on coming at it, something 5 meters away would be detected. But if you said 4 meters, that's about right. These bigger ones, as I say, has got a range of about 7 meters, which is, well, it's a bigger Fresnel cover, isn't it, for a start? Anyway, I'm sticking with these. So what else can I tell you about this project? Right, so you've seen how this works. Oh, I've triggered it off. And really simple it is too, but what you really need a walkthrough of that, so I'll drop that into this video now. Right, let's have a quick structured walkthrough then from this device. Now on the left in that black window, that's the putty window showing you the ambient light level. Anything below 400 means this unit will beep, and anything above 400 means it will just be quiet. Now we've made it appear dark by putting this bit of blue, whatever you call it, putty on top of there. As soon as I take that off, you notice the output level of the ambient light level detector goes beyond 400 and it goes back to sleep, even when it wakes up by being triggered by this PIR device. As you saw there, it says I'm awake. Oh, hang on, the light level's 413. That's far too bright. I'm just going straight back to sleep again. And it will go back to sleep for at least 2 seconds, because that's how long this thing stays active for before it resets itself. Now, assuming that the light level is well, dark basically, so we put this blue tack back on that LDR. So now it's going to be dark, as you can see there. It's only about 100. So when there's movement, as there is now, it bleeps. And the red light flashes as well. And then it says, right, I've been awake for 5 seconds. I'm going to put myself to sleep now until the PIR wakes me up again. That's just A, to save power, and B, to stop it being really annoying if it happens to be triggered too often. Obviously, if there's a cat in the cupboard, you probably do want to be notified quickly, but I figured that was a good balance. Now, this potentiometer at the back, which is effectively a voltage divider with that LDR, so that the analog input A0 on here can detect the level of light falling on here, because as I move my finger away, you see it got lighter and darker there from 300 to 400. That simply sets where that level is going to be. At the moment it's at the mid level. If I turn it left, it becomes far lighter, look, 25, 26, and if I turn it the other way, it just goes way up to the sort of 500-600 mode and wouldn't wake up, because this is in light. If we put my finger on top though, it might be enough to make it wake up. There we are, at 200. So in a dark cupboard now, that would indeed switch on. So whether or not this potentiometer stays as a potentiometer or just as a simple little variable resistor, because you've only got to set it once wherever it is really, well, 2 or 3 times maybe to get it spot on, but that's about it. So the Arduino, well, I say Arduino, the ATMega328P simply has a couple of decoupling capacitors, one of which you can see through that wire, and there's one, there we are, look, the other side, basically across both power pins. This side over here is the analog side, and this over here is the digital side. The designers have kept those bits of the chip separate, so you don't want digital noise ending up on the analog side, because that'll obviously corrupt the signal. And the beeper is simply an output from one of the GPIO pins, as is the same output going to this LED, but for the LED it's going via a resistor, so we don't burn it out. And the PIR is connected to pin 3 on here, so on that blue pin there, it actually goes into pin 5, physical pin 5, but that is in fact GPIO as we know it, GPIO 3 as the wake up pin, and if that pin goes high, it will wake it up. You can make it go low as well, just change the line in the code where it says set the interrupt to rising, set the interrupt to low, which is what we did in video 115. We had a little switch that went low and it made it go to sleep or wake up, whichever way you want to do it. And that's basically it. So that on a PCB is what's going to fit inside that little case that I've got, and that's the little circuit. Very, very simple. Okay, I hope that was helpful and you understand how simple this whole thing is. But as I said, my sponsors have said they'd be more than happy for me to create some PCBs for this simple project, and I've got them. I want to make the PC a particular size so it fits in a case. Let me show you that. So this is my 3-pack battery power. All right, so 3 AA batteries, and that's going to go on the back of this panel. So that's the outside of the panel, that's the inside. So I want the PCB to screw onto those 4 holes, probably. That then to screw with these 2 holes onto the PCB. So we're talking probably something like that. And then all that fits into this little container. It's got an cutout down the bottom where I can drop my PIR through, although quite honestly I think I might just have it sticking out through that hole. I don't think it needs to be that precise. Okay, as long as it detects some movement within 4 meters, it's going to go off. But there's plenty of holes in the actual enclosure itself so you can hear it, and all that then just fits in rather nicely in there. I know I'm looking, it looks like I'm really cack-handed doing this, but that's because I'm trying to do it looking at the camera rather than real life. No binocular vision, you see, on camera. So anyway, that's going to all go in there, and it fits in rather nice. So the PCB has got to fit onto that back panel. Now I might get away with having it half this size, so it might only fit on something like that, because there's not a lot to that circuit, believe me. And I did think about long and hard, surely this should be SMD. With my newfound SMD skills, skills then, all right, is that better? I thought surely a quad flat pack or something like that would be better, but I thought I've got loads of these DIL sockets, these dual inline ones. They are a bit big, but well, does it matter? I've got a big space to put them on. Even if I did use that entire space on there, does it really matter? Do I really want to incur extra cost by buying those surface mount devices? So then I thought, well, how much are they first? How much can I get them for? Let's have a quick look. So I thought I'd look first of all at a local place. Well, I say local, you know, to Britain. And they're $3.69. I've got it all set to dollars just to make it a level playing field. Now in pounds, that's £2.64 each. Now at this point I'm thinking, hang on, I can actually buy a complete Arduino Nano for less than that. So why don't I just go and buy some nanos, desolder the chip off using my newfound, don't laugh, newfound skills of desoldering stuff, and just desolder the chip and put it onto a new PCB. I mean, why not? I can get it cheaper than that. And I thought, well, okay, maybe I can buy the chips cheaper then from China. So let's have a look at how much they are there. So one of the places I went to was AliExpress, because they sell everything under the sun. And here you can buy 10 of these chips for $10.32, which makes them $1 a chip, doesn't it? So that's pretty cheap, but you got to buy 10. And I thought, even if I bought 10, am I going to use 10 over the next 5 years? Maybe, maybe not. Depends how many of these little things I make. So I make one for me, a couple for the neighbour. That's have you got a calculator? That's 3. Then what do I do with the other 7? Keep them in a box? Well, they could be there forever and a day until they're obsolete, couldn't they? So I have to watch things like that. I don't buy too much in one go. And I couldn't find anywhere on AliExpress that actually sold them individually. Now you can get them on AliExpress, of course, these DIL ones, but I don't want those. Now this is interesting though. Look, this is the ATMega328P Pro Mini. Now this individually, if you buy just one, well, there's lots of options. Look, most of these options are in fact how to program the thing. So, you know, things like FTDI, USB to serial converters. So this whole thing, this Pro Mini, assuming that the chip is in fact a genuine one, is $1.71. So you can buy a couple of those, as I say, desolder that chip, or desolder the LED on it and any other thing that you don't need on that, like the voltage regulator. I think that's the voltage. I can't see it. I haven't got my glasses on, but I think that's the voltage regulator, for example. But whatever, if it's got one, take it off. You don't need it. Any spare capacitors and resistors that we're not using, take those off, although they probably wouldn't come to any harm. So yeah, and of course it's got the reset button all built in. So something like that could work for this project. Then you just leave that board as it is and plug that in to the other board that I'm going to make with all the rest of the components on it. That could be an option, except I'm not going to go down that route now. As I said, I've decided I'm going to stick with my DIL sockets because I've got lots of them and I've got room on that board to actually put them on. And yes, they are therefore through hole soldered components, THT components, but I don't really care that much about it really. If I had some SMD stuff, I probably would use it instead, but as I haven't, don't care. And when you think what else I've got here, I've got a beeper, that's the through-hole component. I've got the PIR, depending on how I mount that, that will be a through-hole component. Depends exactly after I've mounted it on leads or not. The two capacitors, well, the two I've got there, I've got loads of those as well. That's another through-hole component rather than SMD stuff. Whether I leave the LED on, I don't know, but there's a resistor at the back. The other thing I might need is some kind of reset switch, because I have noticed with this particular chip, when the power's applied, it doesn't always start up. It just sort of sits there, and I don't quite know what it's doing at that point. Maybe the power isn't being applied quickly enough, ramp up enough, I don't know. But once you've reset it, it works. So I might need a little reset button on this device. Got plenty of those buttons, believe me, little tiny things, but they're all through-hole components as well. So everything on here really is a through-hole component, isn't it? Oh yes, and the LDR, that little thing you see at the back, that's a through-hole component. I'm certainly not going to change that to an SMD one. So there we are. Looks like this is not going to be an SMD project, but it will fit on a board like that. So if you're a beginner, or well, not that much of a beginner, but you know, if you're looking for a project to make that is useful, and dare I say it, if you built one of these and put these, if you're living at home with your brothers or something like that, you could put one of these in a cupboard and change the wiring subtly. Soon as somebody opens the door so that light comes in, the alarm would go off. That'd be good, wouldn't it? Stop your siblings stealing your stuff. I didn't tell you that though, don't get that from me. Right, okay, that's it. The circuit diagram probably explains it all. The PCB hasn't been designed yet. That'll be for a future project, possibly next video, but it might not be. It might be the video after, but see how much time I got. And yeah, that's probably about it really. So as a beginner project, I think this is probably a good one. You learn about deep sleep, you learn about interrupts, you learn about how to minimize power, even though it's not just deep sleep, it's other things like that variable resistor, and LDR is actually powered from that chip, remember, when the chip wakes up, so we don't waste power by having power running through that all the time. It's a nice little project to do, and it will run from batteries. You can get cases like this all over the place, and if I find the link to this actual case, I'll put it on my GitHub and in the video description down below. Talking of down below, if you can put your comments down there, that would be great. And if you like this video, give it a thumbs up. That tells YouTube that it was worthwhile making. Please do visit my sponsors. They'd appreciate that. Remember, you can get 5 boards for $2 plus your shipping fee. Excellent value, excellent quality. And well, you'll see how excellent they are in the future as well. But if you look back at some of my videos, you'll see how good they are there as well. So thanks to PCBWay for sponsoring this video, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.